right, so here becomes our first example for graphing a rational function. And the idea is that we want to use all of these key features that we've been talking about over the last few days to be able to plot this graph. So with y equals x squared plus x minus 12 over x squared minus 4, we will begin by using the factored form. And that's because the factors really help us to locate what these key features are and what they're doing. Okay. So the numerator factors to x plus 4, x minus 3. And the denominator factors to x plus 2 and x minus 2. Going through our list of key features, wholes occur when there's a common factor in the numerator and denominator. There isn't one, so we'll say none. There are no wholes for this function. VA stands for vertical asymptotes. So vertical asymptotes occur when there are factors in the denominator. So we're going to have two vertical asymptotes this time, x equals 2 and x equals negative 2. And those come from setting each factor equal to 0. So x plus 2 equals 0, so x equals negative 2. And then x minus 2 equals 0, x equals 2. Horizontal asymptote is where we look at the different cases. So in this case, exponents are the same, so we're going to divide the coefficients. So 1x squared over 1x squared, our horizontal asymptote is at y equals 1. X-intercepts occur when there are roots or factors in the numerator. So x plus 4 equals 0, so we're going to have an x-intercept at negative 4, 0. And then x minus 3 equals 0, we're going to have another x-intercept at 3, 0. To find our y-intercept, we put 0 in for x, and then simplify. You can also go back to the original problem, and that's kind of what I tend to do because the terms with the x just kind of cancel once you plug in a 0, and you're left with just dividing the constants to get the y-intercept. So negative 12 divided by negative 4 is 3. So our y-intercept is 0, 3. Okay. Let's go ahead and plot what we know, and then we'll test more points if we need to. Our vertical asymptotes are at x equals 2. So I'm going to put in a vertical line at 2, and then at negative 2. And then we have a horizontal asymptote at y equals 1. So at this point there's 1, 2, 3, 4, 5, 6 kind of chunks to our graph. And I know that I'm going to have a piece of my graph on the left-hand side of x equals negative 2. I'm going to have a piece of my graph in between the two vertical asymptotes, and then I'm going to have a piece of my graph somewhere on the right-hand side. Okay. For our x-intercepts, we know negative 4, we know 3, then we know our y-intercept of 3. In this case, I feel like we've got enough key features to go ahead and plot. We won't need to test more points. And the reason why is we have a point located in each one of these quadrants, or not really quadrants, but each one of these sections of our graph. And we know that on each section, the graph is just going to curve or hug along those asymptotes. So on the right-hand side, we have this x-intercept of 3, and so we know that it approaches that line of y equals 1, passes through the x-intercept, and then it would approach the vertical asymptote. Okay, so that's what the right-hand side of our graph would look like. The left-hand side is kind of doing the same thing, right? So we're going to come down and come across. And now we need to figure out what's going on in the middle or in between the two vertical asymptotes. Sometimes graphs will come down or approach one side of a vertical asymptote, pass through, and then approach the other side of the other vertical asymptote. In this case, there's no more x-intercept, so we know that's not what's going to happen. I know that this graph is going to come down, pass through that intercept, and then come back up. Okay. So that's it for our first example.